I'm Eric Siegel, CEO and co-founder of Gooder AI, and in this video, I'll cover why predictive AI projects must be valuated. That is, why we must estimate the profit, savings, the monetary performance, or other business metrics or KPIs, rather than only the technical performance metrics that are standard, like AUC, precision recall, even accuracy is a technical metric. So I love this quote from Morgan Vater in the foreword to my book, The AI Playbook. Machine learning's practical deployment represents the forefront of human progress, improving operations with science. But predictive AI projects usually fail to launch. In industry research conducted by Rexer Analytics, and this was a research project I actually had a hand in on, only 22% of data scientists say their new initiatives usually deploy. And others have seen similar results from industry surveys, industry research, including IBM surveying not the data scientists, but the executives, saying that predictive AI's average returns are lower than the cost of capital. So essentially no returns. That is to say you do just as well investing in an index fund. Our thesis is that predictive AI projects must estimate the business value pre-deployment, before you deploy initially, and then also before you change the deployment or refresh the model, etc. The corollary is that not doing this is why most models, or at least one of the main contributing factors, in many cases the main factor, why most models fail to deploy. So just to be clear, we're talking about the difference between technical and business metrics. Typically, the data scientist assesses, evaluates the performance of a predictive model over the test data using metrics like precision recall, area under the curve, F-score, and these only tell you the pure predictive performance of the model. The relative performance, a comparison to a baseline like perhaps random guessing. And indeed, we don't have a magic crystal ball, and predicting better than guessing is generally the most we can hope for, and is usually sufficient to drive an improvement to the bottom line and deliver value, but they don't tell you anything about how much value. Why not also assess the performance of the model in monetary terms, in terms of business metrics like profit and savings, or any other KPIs that matter to the organization? So that is to say, not just do standard ML evaluation, but also do what we call ML valuation. You know, if you build a rocket, you can't launch it until you've stress tested it in its intended usage according to the KPIs that matter. If you build something, you've got to check out how good it is before you're potentially going to use it at scale, right? Like any other operational improvement, even with or without analytics, you can't move forward until there's a credible, concrete, informed estimation of how much it's going to improve those operations. In terms of the lingua franca of business, the things that matter, the KPIs, the business metrics. In general, you've got the data scientist on the left here talking one language that the business person doesn't necessarily care about. From their perspective, technical performance metrics like lift, precision recall, accuracy is a technical metric also. They're arcane as heck because they are very disconnected. They don't give you any information, or very little information, very indirect information about the potential performance. Why don't we also go right on the nose? What's the money or the other KPIs that matter? Profit, return, savings. The Harvard Data Science Review said that technical metrics are fundamentally useless to and disconnected from business stakeholders. Data scientist Henry Castellanos, who's a Gooder AI user, always says things along the lines of don't show a confusion matrix to executives. This research paper says something similar, that those statistical, that is technical performance metrics, don't tell you, the business leaders, what they need to know. I bring this up a little redundant because that research paper has some views such as this one that show the problematic scattered relationship between business and technical metrics. So the x coordinate from left to right, that's the technical metric. That's one of the standard performance metrics of the model. In this case, area under the precision recall curve. So as you go from left to right, the model's getting better in the eyes of the data scientists using that type of technical metric. The y coordinate from top to bottom, that's business value. It's a business metric, in this case, loss. So lower is better. It's the loss due to fraud if you're using the model that's being evaluated for fraud detection. So it takes into account both the false positive and false negative costs. So false negative, that means we don't capture the fraud, then we suffer the cost of the fraud. False positive means we wrongly block or audit a fraud, in which that also incurs a cost, although a lower cost. You add those up depending on the performance of the model, and it can be translated into that business metric. That's the thing that matters, is the y coordinate. As you can see here, there is something of a relationship. As you go towards the right, according to that dotted line, yes, as you go to the right, the business metric does tend to go down somewhat, a bit, on average, but there's no direct correspondence. It's all over the place. It looks like it might as well be random. That is to say, as you pursue the technical objective that's standard to the data scientist and improve it according to the technical metric, you're definitely not necessarily improving the value of the model for the business. Now, data scientists in general jive with this. They nod their heads, from my experience, almost universally. And in fact, that same survey that I was involved in, the industry research conducted by Rexer Analytics, showed that they know this but don't act on it. So they list as most important metrics those kinds of business metrics like returns and revenue, but then list as the most common metrics they actually use in assessing the performance of a model as those technical metrics like lift and area under the curve. So this kind of profit curve, when we covered this in another video, we described what a profit curve is and why it's so important, is very, very rare. Because in this case, the y coordinate is profit. It's a business metric. The x coordinate from left to right is where you're drawing the decision boundary, how many individuals are being treated. So that's also rarely displayed. So when you're developing a model as a data scientist, it's a semi-automatic iteration, right? Train test, train test, train test, train test. And the testing part, which is done with human eyes, with human business considerations ostensibly, is entirely neglected in general because it's only done in terms of technical performance metrics. You can't pursue business value if you don't measure business value. So by using business metrics, one of the two main business problems that are solved is that now you can successfully navigate the development of models in order to pursue business value. And the second is you provide visibility to the stakeholders and any associates, anyone at the organization who cares about what the organization cares about, right? Now you can make a business-informed decision based on business considerations to potentially authorize, greenlight the deployment, right? Otherwise, because if a stakeholder is only looking at the technical metric, a sensible stakeholder would get cold feet and would scrub the launch. And in fact, these days, most of those models launches do get scrubbed. So that is, say, between training and deployment, right? You want to assess the performance of the model. How good is it? Check out how good it is before you use it, but not just in terms of technical metrics. What's the value that it will deliver, and how do we decide to deploy it to maximize that value? So that is to say, this is where Gooder AI sits, but it's typically called evaluation. We're saying also use business metrics. We'll call that more specifically ML valuation. Gooder AI is the first and only off-the-shelf solution for ML valuation. Now, it's not just pre-deployment. It's not just at the moment. That's the first time you need to use it, is to get a thing deployed. But once it's been deployed, you're monitoring it. Businesses are constantly striving to improve operations, and of course that applies even after a model's been deployed. You're constantly monitoring how well is this model holding up, how well are operations doing. That's also referred to as ML observability. That needs to also be conducted in terms of business metrics. You're sort of constantly redeploying. You're assessing, should I be changing the way I've deployed it? Should I change the model? That would be a champion challenger comparison. Should I reassess where to draw the decision boundary, etc.? So why are business metrics so rare? Why is ML valuation conducted so rarely in predictive AI projects when it's so critical to get it launched and to pursue value? That's the topic of our next video.